Hello, ladies and gentlemen. Welcome to Math 30-1, Chapter 6, Section 1, Trigonometric Ratios for Any Angle and Standard Position Notes. Now, first part is the unit circle and cast. Here I need you to recall the primary trig ratios. The three of them: sine, cosine, tangent. Sine is the opposite over the hypotenuse, cosine is the adjacent over the hypotenuse, and tangent is the opposite over the adjacent. Now here's something important. I want you to realize standard position means we're in the first quadrant, so we're here. So our opposite is our y. Our adjacent is our x. And our hypotenuse is the radius. Now, as I said, unit circle, radius is 1, but we'll ignore that for the moment. It is the sine will be y over r, cos will be x over r, and tangent will be y over x. Okay? Now, in these four quadrants, you should also remember all the trig ratios are positive in the first quadrant. Only the sine is positive in the second. Only the tangent is positive in the third, and only the cosine is positive in the fourth. Yes, this is quadrant 1. This is quadrant 2, quadrant 3, and quadrant 4. All right? Now, something else you should remember. Sorry. Tangent is the sine of theta divided by the cos of theta. All right? As I said, lots of bits and pieces that you should remember, plus some new stuff. Now, the next bit, we call Pythagoreans Theorem. A squared plus b squared equals c squared. Or in this case, x squared plus y squared equals r squared. Now, I want to stress this. In the unit circle, r is 1. Okay? So x squared plus y squared will equal 1. This leads to a typical deployment question. Point A, 0.68, comma y, is in the intersection point of the unit circle and the terminal arm of theta in the standard position. The coordinates of point A to the nearest hundredth are blank, blank, blank. Now, here, I want you to realize we're somewhere on the unit circle. Now, we're in standard position, here we're limiting ourselves to the first quadrant here. So somewhere, arm is here somewhere. Now, point A is x comma y, so 0.68. We're going, what is y? Okay, so x squared plus y squared equals r squared. Since we're on the unit circle, r is 1. Do I have to write out 1 squared? I should. Somebody will get mad at me. So 0.68 squared plus y squared equals 1. So y squared equals 1. Now what is 0.68 squared? 0.4624. 0.3. So y is the square root of 0.5376, which is plus or minus 0.73. Now, since in this lesson we're stuck in the first quadrant, we're in the positive. Plus 0.73. Okay? So far, so good? Well, I hope so. Okay, now, new stuff, reciprocal ratios. Cosecant, cos of theta, secant or sec of theta, cotangent or cot of theta. Now, this is our sine theta, which is r over y. Secant is 1 over the cos, which is r over x. And cotangent is 1 over the tangent, which is cos of theta divided by sine of theta, which is x over y. All right? Now that is not that new to you. Well, it is new, but have your formula sheet handy. You do. right here. Notice we have cotangent, cosecant, secant. So if you have your formula sheet handy, you don't have to memorize this stuff. The rest comes in handy tomorrow. But come on, go away. I don't want to deal with you. Computers, God help us all. Right, moving on. Angles in standard position. So this is where it gets interesting and where I expect you to do some thinking. I want you to find the angle, find the initial arm on the x-axis, rotate the terminal arm clockwise. So first thing, put the arm on the x-axis. Second thing, rotate the arm counterclockwise and find the angle. Now be careful. You might find a reference angle. That is, Mr. Calculator will by default find this angle, the angle between the terminal and the nearest x-axis. Okay? Now let's do a couple examples on that. So, if theta is 130 degrees, then determine two positive angles coterminal with 130 degrees. So 130 degrees is like that. Now coterminal means you do a complete rotation beyond that. You keep on going. And you come here, another rotation. So that is plus 360. So that is what? 490 degrees. Okay? So 490 degrees is coterminal, or the same spot as 130. What's the next coterminal arm? Well, add another 360. Do another rotation. And what do you get? 0, 5, 850 degrees. So if I asked you to draw 850 degrees or 490 or 130 degrees, they'd all be right here. All right? Now, determine two negative angles coterminal with 130 degrees. So if 130 degrees is here, what's negative means we subtract 360 degrees. We go backwards. What do we get? 260 minus 230. Okay. If we go back again, minus another 360, we get minus 590 degrees. So, minus 230 minus 590 and 130 degrees all end up right here. And they all look the same. So, instead of listing all of these, we give the general expression. That's 130 degrees plus n times 360 degrees. Notice it's multiples of 360, where n is an integer. Now, that's general expression. That means it works. Come up with an integer. 11, 73, minus 20. They all work. Now, sometimes on the exam, they use this funny looking z. All right? Now that's just to confuse you. Something, I think it's German for integer. But that's what they're talking about here. So this is a general expression. Any integer you can plug in there works. Okay? Now that's enough for this first part. I want you to take a look at this and think about it, and then we're going to go on to special triangles. All right? Good luck. Good luck.